Bismillahirrahmanirrahim. So we continue with our previous example of investments. We had three alternatives apartment building, office, and warehouse. And we had two states of nature, favorable market and unfavorable market. And the probability of favorable market is 0.6 and probability of unfavorable market is 0.4. And in this table, payoffs are according to the alternatives and the states of nature. So we have already seen this example. We now say that we have a opportunity. We have an opportunity to go for report from consultants or not. The consultants have this statistics which we discussed earlier, is that they say that they have studied some 250 cases in which 150 times the markets were favorable and 100 times the unfavorable market occurred. And they say that what their positive reports were 80% of the time for favorable market, and on the other hand, their negative reports were occurred 20% of the time when the favorable market occurred. And this similarly they had other statistics is reports positive when the unfavorable market occurred was 10% of the time, 0.1, and report negative occurred given that unfavorable market occurred was 0.9. Having this statistics, now we can work out that what would be the probability of getting favorable market given that the report is positive, or what is the probability of getting unfavorable market given that the negative report has come, etc. And this will help us in decision making. So we will see there are now two sequence of decisions we have to make. The first decision is whether to go for report or not. And if we go for the report, then there are two states of nature. Either the report will be positive or negative. And then we have the second decision to make is about these alternatives: apartment building, office building, or warehouse. We can invest in these three alternatives, and then the actual state of nature may occur about favorable market or unfavorable market. So we will draw this decision tree, and we have said earlier that decision trees are helpful in sequential decision making. So now we have this sequence of decisions. First decision is to whether to go for report or not, and the second decision about investing in these alternatives. So what I'm going to do is I'm going to draw the tree, and let's we already have, remember that we have already worked out in the previous part the probability of favorable market given that positive report has come, and probability of unfavorable market given that positive report has come, and etc. All these different probabilities have already been worked out, so we will be using that. So I'm going to draw here the decision tree. The first decision to be made is whether to go for report or not. So the decision node is a square node, and here we have the first decision: go for survey or report. And no survey. Now we will assume that the survey or the consultants are asking for $1,000 for making this report. Then we said that we have two states of nature. The first is, or the one is that the report is positive report, and here we have, let's say, we have negative report. Okay. And then the second decision to make is whether to invest in apartment building, office, or warehouse. And here again we have, three decisions. Whether the negative report or positive report, we still have these three decisions we can make: apartment building, office, or warehouse. All right. And then if we don't do survey, we still have these three alternatives that we can invest in: apartment building, office, or warehouse. All right. Then the actual, what we call it, the actual state of nature may occur. The market could be favorable. Market could be favorable market, or it could be unfavorable market. Favorable market or unfavorable market. Favorable market or unfavorable market. And then we have here favorable market, unfavorable market. Okay, well, it's a little bit messed up, but I suppose it's okay. Favorable market, unfavorable market, and then we have this again: favorable market, unfavorable market, and then we have this: favorable market, unfavorable market, favorable market, and unfavorable market. And then at the end we can put the payoffs. Now the payoffs are okay. We said that the consultants are charging $1,000 for doing the survey. So here we have the report go for survey, then it means they are paying $1,000, and we put, when we invest in apartment building and the market is favorable, our payoff is $50,000. Okay, so we put 50 instead of putting 50,000, we can put $49,000. All right, because 1,000 paid there. Similarly, instead of putting 30,000, we put 29,000. Okay, and then similarly we have 100,000, we put 99,000, and this was minus $41,000, right? And then this one was $29,000, and $9,000. And same way we have, since this is coming also from the paying to the consultant, negative report is also coming from the consultant. So 49,000, and then we have $29,000, and here we have for office we have $99,000 and minus $41,000, and for warehouse we have $29,000 and how much was that? 10,000, so 9,000, yeah. And then here, since this branch is coming from no survey and apartment building, we have the payoffs, previous payoffs. What are those? We have 50,000 here, right? 30,000 here, and here $100,000 and minus $41,000, and this was $30,000 and $10,000, because here we don't pay $1,000. If we don't go for the consultants, our original statistics or original shows probability that favorable market will be 0.6 and 0.4 and 0.6 and 0.4, 0.6 and 0.4. Okay. If we go to the survey, go for survey, and we have favorable market, given that the positive report has come, we already have worked out the probability, and that is 0.923. Probability of favorable market, given that positive report has come, is 0.923. So this one will be favorable market, positive report here. So we have favorable market, given that positive report has come, is 0.923, and here we will have 0.077. This will be the same. Favorable market, given the positive report has come, 0.923 and 0.077 and 0.923 and 0.077. And then what is the probability of favorable market given the negative report has come? So we have already this one, favorable market given the negative report come is 0.25. This is 0.25 and this is 0.75. 0.25 and 0.75, 0.25 and 0.75. All right. So our decision tree is now completed. What we can do is now we can work out the expected values, and we can put these expected values on the notes. So what we have is, this will be, I suppose, this is 49,000 multiplied by 0.923 plus 29,000 multiplied by 0.077. So what we are getting, 49,000 multiplied by 0.923 plus 29,000 multiplied by 0.077. What we get is 47460. So we will put over here $47460. Okay, And then similarly we can put out the other values here. It is, I will just copy them from book 1888 $220, and this will be, I suppose, $27,460. Okay, we put other values as well. This will be $34,000. This will be minus 6,000, I suppose. Okay, and this will be $14,000. And this we already have, which was the expected values. Expected values were there. This is, I suppose, this is $42,000, $42,000. This is $44,000, and this was $22,000. Yeah, 30,000 multiplied by 0.6, 18,000 plus 4,000, so it is 22,000. So we have 22,000 here. Okay, go back to note. Now you can see we have to pick the best alternative in each state coming here. When the positive report is there, then the best alternative is office. So we discard this apartment. Let me use other color. Let's say we get which color we use. That's a green. Okay, so we discard this one, apartment and warehouse. All right. And similarly in the negative report, the maximum is coming from apartment building, so we discard office and warehouse. And down there the best is office, so we discard apartment and warehouse. And then we put the best values here. The best values are $88,220 and $34,000, and this one is $44,000. Now the probability of getting positive report was 0.52, and the probability of negative report was 0.48. So we weighed this to find out the expected value, and that would be 88,220, 88220 multiplied by 0.52 plus 34,000 multiplied by 0.48, and what we get is 62194. $62194. All right, and similarly we can get here is 44,000. So the best value which is coming here is $62,194. As we can see that the maximum payoff or maximum expected value is coming from going for survey, so no survey is discarded, which means that we will take the decision to go for survey, go for the reports from consultants. We may have to pay $1,000 for that, and then we if the survey is getting positive report, then we will invest in office, etc. So this is the sequential decisions. Now, what if the consultants want to charge us $20,000? Should we pay to them? That will come from the expected value of survey information. Like we have done expected value of perfect information, this can be found from expected value of survey information. So we have expected value of survey information is equal to expected value with survey information minus maximum expected value coming from no survey or without report. Okay, so we have expected value with survey information. But we have paid also. So we will say expected value with survey information plus the cost of survey. I should add plus cost of survey here. Let me remove this again. And expected value with survey information plus the cost of survey minus the maximum expected value without report. Okay, so expected value of survey information is then $62194 plus the cost of survey was $1,000. All right, minus the maximum expected value without report was $44,000. Okay, so we have the expected value with survey information, expected value of survey information is then equal to $19,194. This is the expected value of survey information. This is the maximum willingness to pay to the consultants. So if their consultants are charging, let's say, asking for $20,000, we will say, sorry, we don't want your services. On the other hand, if they say, let's say, they can charge up to 19,000 or so, we will value that and we can take their services. One last thing is what is the efficiency of expected value of survey information. That efficiency of survey can be found is equal to expected value of survey information divided by expected value of with perfect information, or expected value of survey information divided by expected value with expected value of perfect information. So here is the so $19,194 divided by, and as I recall, expected value of perfect information was $28,000. So what we get is about 0.69 or 69% is the efficiency of survey. All right, now what I will do is I will quickly go through these slides. So decision analysis with additional information is called Bayesian analysis, and Bayesian analysis is used uh, additional information to alter used when additional information is there to alter the prior probabilities, and the revised probabilities are called posterior probabilities. Now, in the real estate investment example, using the expected value criterion, the best decision was to purchase the office building with an expected value of 44,000 and expected value of perfect information of 28,000. Now, through discussion with an economic analyst, the investor has learned the following. He can use this information Bayes theorem to calculate posterior probabilities, and we said that this is the statistics available to us through the economic analyst. The positive report, which predicts favorable market, is given that favorable market occur is probability of positive report given the favorable market is 0.8, and probability of negative report given the favorable market is 0.2, and probability of positive report given that unfavorable market is 0.1, and probability of negative report given that unfavorable market is 0.9. We have done that. We assumed actually that they have some about studies of 250 cases, and in this 250 cases 150 times the favorable market occurred, and about 100 times unfavorable market occurred, and from there the statistics shows that it is 0.6 is the probability of favorable market and 0.4 of unfavorable market. And then these positive reports, we said that maybe 120 out of 150 were positive reports, and about 30 of them were negative reports where the favorable market occurred, and in the when the unfavorable market occurred, negative reports were 90% correct and 10% were incorrect. And from this information, we can revise our probabilities. We can make our posterior probabilities. The initial probability are that favorable market chances are 0.6 and unfavorable market 0.4. Now what we will do is we will revise these probabilities, that what is the probability of getting favorable market given that the report has come positive, etc. So this is the use of Bayes theorem. The Bayes theorem is, we have discussed that. This is the Bayes theorem here. And using this Bayes theorem, we get all these different probabilities. Probability of getting favorable market is initial probabilities are, prior probabilities are this one. And then we have probability of getting favorable market given that positive report has come is now 0.923, and the other rest of the probabilities are given, worked out. And finally, we can use also Excel to calculate these posterior probabilities. Decision analysis with additional information, decision tree with posterior probabilities. Now, decision trees with posterior probabilities differ from earlier versions that the first decision point is whether to go for report or not, and when the decision to go for report taken, two new branches of state of nature represent report outcomes, and the second decision point is then the investments in alternatives. Probabilities of each state of nature for the survey option are posterior probabilities from Bayes' rule, and we assume that the report is not free and has costed us $1,000. So this is the decision tree with posterior probabilities, and you can see that the conducting the survey is giving us the highest or higher expected value, so we will discard do not conduct survey. And of course, if the positive report comes, we can invest in office building. If the negative report comes, we can invest in apartment building. And to find out the expected value of the survey information or with report is 62,194. And then if we want to find out what is the expected value of sample information, EVSI, then it is expected value with sample information plus the cost of survey minus the expected value without sample information. And here is the expected value of survey information is equal to 19,194. And the efficiency can be found out by expected value of survey information divided by expected value of perfect information. We get 69%. So far we have done this. I have repeated the all the lectures from slides now, and the last topic is utility. Now, there are certain decision situations in which individuals do not make decision based on the expected dollar gains or loss, but rather subjective value to utility. Utility is a measure of personal satisfaction derived from money, or utiles are the units of subjective measures of utility. So utility is actually a personal satisfaction derived from money, and it is very subjective. For example, a person who is earning, let's say, 300 reals per month, if we ask him that we will give you 2,000 real to do a strenuous job under the sun in June heat in Oman, for example, we will give you 2,000 real if you work for 1 week under the sun. That person whose salary is 300 reals would more likely take this job offer. However, if a person is earning, let's say, 2,000 reals per month, and he's asked that you have to work for 1 week under the sun and we will give you 2,000 real, he might not take that job. So it is very subjective one. The utility is a measure of personal satisfaction derived from money, and it depends from one person to another person, so it is very subjective. Now, following example of car insurance explain the concept. We have, let's say this is the statistics that the accident doesn't occur 99.2% of the time, and only 0.008 probability is there of occurring, which means 0.8% occurring chance occurrence is there. Now, the decision is whether to purchase insurance or do not purchase insurance. If we purchase insurance, the expected value is $500 here. And if we do not purchase insurance, then the expected value is 10,000 multiplied by 0.008, which is $80. Expected value of the or cost of insurance, on getting the insurance or not getting the insurance. So if we don't, if we go for the expected value decision, we can see that this is the cheapest decision here. Do not purchase insurance, but more or less people always buy insurance, car insurance, especially if you are traveling outside. Here in Oman, of course, the insurance, you have a mandatory insurance third party. But let's say if you are traveling abroad and there is a what we call it, an opportunity not to buy insurance, still we will buy the insurance. So this is we are trying to avoid the risk. These are called risk averters. Risk averters forego a high expected value to avoid a low probability disaster. And then there are risk takers also, which take a chance for a bonanza on a very low probability, even in lieu of a sure thing. For example, people gamble and they buy lottery tickets, and only 1 in million chance is there, or 1 in 10 million chance is there that they will win. So it is almost zero probability is there, very low probability is there, but still people buy and they take the risk. So if we go for the expected value thing, they will not do that. So although the concept of utility is realistic than the expected monetary value concept, its application is difficult as it is based on subjective preferences of individuals. Some may give high value for certain amount of money, another may give a low value, and so it becomes difficult to use this concept. So by and large, the individual may make decision based on their utility, how much they prefer, how much they give value to the money, but for organizations, they should take decision based on expected value. All right, we will see one sample problem, and then you can look at some of the problems in the slides, and also there are some solved problems in the book, as well as we have given you homework, and in that homework we have supplied you some solutions, some answers only, and you try yourself. So I'm just going to discuss only one problem here as a sample. Let's look at the sample problem. Orders for clothing from a particular manufacturer for this year's Eid shopping season must be placed in the month of Muharram. The cost per unit for a particular dress is Riyal 20, while the anticipated selling price is Riyal Omani 50. Demand is projected to be 50, 60 or 70 units. There is a 40% chance the demand will be 50 units, a 50% chance that demand will be 60 units, and a 10% chance that demand will be 70 units. The company believes that any leftover goods can be sold to a discount store at Riyal 10. How many units should be ordered in Muharram? Now, if you see this problem is a little tricky, that we find the demand and its probabilities. So we find the states of nature, but we don't know the alternatives. In fact, if you look at that, the alternatives are in our hand. The difference between a state of nature and alternative is that state of nature is not in our hand, whereas the alternatives are in our hand. We can decide about what to do. So if we know the demand is going to be 50, 60 or 70 units, then our alternatives can also be, we can make 50 units, 60 units or 70 units, and that is the only trick in this problem. The rest is easy. Let's see the next slide to see how it is solved. So we make the alternatives, order 50 units, 60 units or 70 units, and the states of natures are either it could be 50 units, 60 units or 70 units, and their probabilities are given. Now let's say the selling price was 50. All right, selling price is Riyal 50 and the cost is Riyal 20. Real 20. So the profit was, or the payoff was per unit, profit per unit. What happened? Previous. Oh no, not previous. We go. What happened? Let me go back. Previous. Okay, so the profit per unit is equal to Real 30, and this is also per unit. Real 50 per unit selling price, and 20 Real cost per unit. So from here we can work out the profit is there, that we can work out the payoffs. So if we order, let's say 50 units, and the demand is also 50 units, then we are able to sell all of them, and we will have 50 multiplied by 30 Real profit per unit. We will have 1500 payoff. And same way, for if the demand is 60 units and if we have ordered 50 units, we will only sell 50 units. So again 1500 and also 1500, and the expected value is 1500. Let's look at the second case, alternative 60. We made 60 dresses, and here we are if the demand is 50, then we will be only selling 50 units, then the payoff will be 1500. Okay, but 10 units are unsold. When 10 units are unsold, their cost is 10 multiplied by 20 is 200, and but we can sell it to, these 10 units can be sold to discount store at 10 Reals per unit. So 10 multiplied by 10 is 100, and this is the cost is minus, and then this is again a profit. So we have 1400 altogether, this payoff. And if we order 60 units and the demand is 60 units, then 60 multiplied by 30 is 1800, and again it is 1800. If the demand is 70, we will only be able to sell 60 units. So this is, and the expected value is just multiply with the probabilities of these payoffs. You get 1640, add them all. And if we order 70 units and the demand is 50 units, then of course we will be able to sell 50 units only, and the demand will the payoff will be 1500, and 20 units are unsold. So 20 multiplied by the cost per unit is 20 again, and this is 20 multiplied by 20. But these 20 units can be sold at the discount store with $10, 10 Reals per unit. So this is 20 multiplied by 10, and eventually we get 1300 payoff. And similarly here we get 1700 payoff, and if we order 70 units and able to sell 70 units, then we will make 2100 Reals, and this is the expected value. So the highest expected value is coming 1640, and we will order 60 units. So this is a nice problem. The only big trick, or the first trick, was about the alternatives, and if you decide the alternatives, then it was easy. There are other problems also. For example, this problem is there. This is just making use of Bayes' theorem. You have to revise the probabilities. You can do it at home. And then there's another problem in which we have let me read it. Saleh Al Faruqi is considering opening a competing bookstore near the campus, and he has begun an analysis of the situation. There are two possible sites under consideration. One is relatively small, while the other is large. If he opens at site 1 and demand is good, he will generate a profit of $50,000. If demand is low, he will lose $10,000. If he opens at site 2 and demand is high, he will generate a profit of $80,000, but he will lose $30,000 if demand is low. He also has the option of not opening either. So do nothing is also an option here. he believes that there is a 50% chance that demand will be high. So this is we can say that this is the initial probability here. Saleh, which means 50% chance is high, then 50% is of course low. Saleh can purchase a market research study at the cost of $2,000. Okay, the probability of a good demand given a favorable study is 0.8. Now, probability of good demand, okay, given that a favorable study, which means probability of favorable market, if you like, we can use the same symbols, given that the favorable study, which is positive report is equal to 0.8, and the probability of a good demand given an unfavorable study is 0.1. So the probability of good demand, probability of favorable market, we can say that given that unfavorable study, which is negative report, is equal to 0.1. All right, then we can, and there is a 60% chance that the study will be favorable. There is a 60% chance that favorable, which means positive report. Probability of positive report is equal to, come on, not working here, is equal to 0.6, which means that the probability of negative report is 0.4. Okay, the other probabilities can easily be worked out here. Probability of if this is the favorable market given the negative report, what is the probability of unfavorable market given that negative report is there, is 0.9, and this one, probability of unfavorable market given that it is positive report, is just 0.2. Now we have all the probabilities. As you can see over here, we don't have to do the revised probabilities in this problem. Why? Because we already have probability of favorable market given that positive report is there, or probability of negative report, probability of unfavorable market given a negative report is there. Similarly, probability of favorable market given that positive report is there, the probability is there, and probability of unfavorable market given that positive report is equal to 0.2. We have all these probabilities. We don't have to revise them. We just make the decision tree, and with two sequence of decisions, and that is given in the next slide. I will not go through this all. We can see that initial decisions are to conduct market survey or do not conduct survey, and then the survey could be positive or negative if we go for survey, and then there are two sites, site 1 and site 2, and do nothing option there. And for if we go for survey, or survey is positive or negative, in all these cases we have three options. And if we don't conduct survey, also we have three options there. And then the payoffs are given. As you can see that we have paying for the study as $2,000. So these payoffs are the difference of this payoffs and the difference of these payoffs are of $2,000. We'll work out the final expected value, and the expected value is coming from the conduct market survey is the highest here, which is 32,800, and this is the expected value of survey information, and this is the expected value with survey information, and this is the expected value without survey, and then expected value of survey information is the expected value with survey information, which is 32,800 plus the cost of survey minus the expected value without survey, and this is the expected value of survey information. I think that's enough for this decision analysis. Let's stop this. Thank you very much.